This is a mix for the wave parameter key area of National 5 Physics, and it's about the characteristics of waves. What you need to know in this section is you need to be able to describe waves using wavelength, amplitude, frequency, period, and speed. You need to be able to make calculations for all these quantities from diagrams and from numerical information. Here's an example of a wave, and this is one complete wave. One complete wave is an up and a down. The length of one wave is called the wavelength. My arrow seems to have moved, so my arrow should be from the end to the start, so it really should be from there to there, from the point of one wave to the same point on the next wave. Wavelength can be given the symbol lambda. It's sometimes like that, or often it's like that one there too. Okay, so lambda stands for wavelength. The axis is the line through the middle of the wave pattern. If you think about water waves, this is what it would be like if the water was completely flat. This is where there is no disturbance at all. The crest is the top part of the wave, sometimes also called the peak. Either is okay. The trough is the bottom part of the wave. The amplitude of the wave is the height of the wave from the axis, from the middle to the crest, or from the axis to the trough. If you're indicating on a diagram, make sure your line covers all that distance. We have the period of a wave. The period of a wave is the time taken for one wave to be produced. Period has the letter T, capital T, and is measured in seconds. Frequency of a wave is the number of waves each second, and is measured in hertz, which is abbreviated with Hz. The abbreviation for frequency is F. Frequency just means per second. We can calculate frequency by dividing the number of waves by the time taken. So this is a useful relationship, but it is not on the relationship sheet. It is something that you have to remember from your definitions. Here is a diagram of a wave that you'll find in your documents as well, and you should be able to label the wave with all the details that you need. You should also be able to match the descriptions to the labels. Here are the answers. Okay, the one that's missing from this is the period, the time taken for one wave that was on the previous slide. So you can solve from diagrams. What is the amplitude of the wave? Well, the amplitude of the wave is the height from the middle to the top. And it's not 5 meters, it's 10 meters. Because that is the distance from the middle to the top. Take care to label it well, unlike mine there, so you need to go all the way from the middle to the top, or you could do it from the middle to the bottom. What is the wavelength? So the wavelength is the distance of one wave. So in green, a wavelength is from there to there, which is 0.1 meters. or a wavelength could be from peak to peak, or it could also be from trough to trough. The number of waves in the diagram is 2, one up and down and another up and down, so 2 waves. Let's look at some calculations you might need to do. If 10 waves are produced in 2 seconds, calculate the frequency. Well, frequency is the number of waves in a second. So we could do n divided by t, and we get 10 divided by 2 gives us 5 Hertz. Second example, a wave machine produces 120 waves in a minute. Calculate the frequency. Formula, 60 seconds this time, because this is a minute, and that gives us 2 Hertz. Try and get used to looking at information and saying, that is F, that is a number, that is my time, because that will help you pick the right formula when you've got a choice of all the formulas. A bit more about the period. The period of a wave, as we said earlier, was the time taken to produce a wave. It is related to the frequency. If the frequency is 2 Hertz, that means there are 2 waves in a second. 2 waves in a second means that the time to produce 1 wave is half a second, or 0.5 seconds. You can use the relationship t, period, is 1 divided by frequency to work out the period of a wave. And that's what we did previously. We said the frequency was 2, so the period is 1 divided by 2, 0.5 seconds. Here's an example. Calculate the period of a wave if the frequency is 20 Hertz. So you should be looking and saying that is T, that is F. What is my formula? T equals 1 over F, 1 divided by 20, 0.05 seconds. So finally, calculating the frequency. T, the period of a wave, is 10 ms. Calculate the frequency. The period is 10 ms, 10 m means milli, so 10 divided by 1,000 seconds, or 10 times 10 to the minus 3 seconds. Write the formula, then we've got to change it around. Remember, you can still use that in a triangle, T there, 1 there, F there, cover up F, and you get 1 divided by the period. Substitute in your numbers, making sure it's in milliseconds, and you get your frequency. This is quite common for a multiple choice type question.